thank you, Piotr. Yes, Paul Hartmann from JOANNEUM Research, well known to some of you here already. The second talk of JOANNEUM Research today, and I will go much more into detail of the lighting applications that we do based on our roll-to-roll imprinting solutions. And I also invite you to our booth that we have there if you want to learn more on the samples. So, yeah, the Institute's materials in a nutshell is consisting of 5 different research groups where optics is just one of those, and we have also organic electronics, we have inkjet printing groups, we have laser groups, we have sensor groups, and a group called Smart Connected Lighting, which is also trying to bring electronic functionalities and sensor functionalities into lighting. Right, that's, we are based in Austria, and that's all that I want to talk about JOANNEUM Research. So, what you've seen already in the morning is that we have been part of the Fabulous, or are still part of the Fabulous Consortium. And within this Fabulous Consortium, we have established a very unique pilot line, but many of these steps can be also provided in-house at JOANNEUM Research. And one of the specialties is that we start with the materials development. So one of the really unique selling propositions is that JOANNEUM Research has own dedicated chemists which are doing suitable materials development for these processes. Then we of course have simulation and design like ray tracing, but also freeform optics. It's all about freeform optics here. And I'll dig a little bit more today into the upscaling process, which starts with the maskless laser lithography or other tools to produce the masters, which are then done by step and repeat, and then by roll-to-roll UV nano-imprint lithography to give a good production process for mass manufacturing. And the biggest quantity of prototyping that we did already on such a pilot line is 10,000 meters for one customer, and that outlines a little bit our goals to be kind of a mass manufacturing provider. Right, here you see some nice examples, starting here from 100 nanometers. Structures, so these are cicada wings that have certain pillars, which are bacteriocytic. Then we can have here this plasmonic applications. Here you can have applications for growing nerve cells here. These consist of steep edges of 1 micrometer height. Then, of course, a big topic is security features. Here you have a very promising application now is riplet voice on aeroplanes. A very big business to reduce the fuel consumption of aeroplanes. Then, of course, the micro-optics, which is the topic of this meeting here as well. And the microfluidics, so same size. So usually here we have 120 micrometers channels. And this one is a especially nice feature. I come back to that later. This is freeform optics for luxury goods, which is gives you sparkling effects. Okay, outlining a little bit the mastering capabilities. So we use flexible grayscale lithography by direct writing procedures. And we can go down here to feature sizes which are a little bit better than diffraction limit, which is 200 nanometers. We are limited to structure heights of 60 microns at the moment, but are working on increasing that significantly in the future. Then we achieve aspect ratios of 4:1, and we can do 1D, 2D, 2.5D structures in freeform with 1 square centimeter per hour on a maximum area at the moment on 6 inch by 6 inch. So what is our future goals in the European Union project? We are currently heavily working on integration of different laser lithography technologies to improve the tooling in one platform. Then we could be able to do structure heights between 100 nanometers to maybe sub-millimeter sizes in 2 and even 3D shapes. So that means that we add to the one-photon lithography the two-photon absorption lithography, which is a real feed process, and also laser interference lithography to be able to produce larger areas in higher speed. Also, we can apply our laser micromachining tools for mastering. Here just a few overview, some femtosecond lasers from different vendors, Toptica, spectrophysics, light conversion, picosecond lasers, nanosecond lasers, and we do have a very accurate and versatile galvo scanner stage, and all that in a clean room class 6. Okay, so making small tools is quite common, but large area tooling is maybe not so easy, and there are several people working on that. So finally, for a roll-to-roll process, you need a large area tool of 650 times 300 square millimeters, and you start with a nickel master, and then you go with a step and repeat process to a polymachine with a rectangular size, and then you can go to a nickel tool by galvanizing that. At the end, you can end up with a roll sleeve that you can use then for roll-to-roll nano imprinting. That's the goal. The way is not so easy, but we are quite we are good on the way to get here. How we do that? Colleagues from EVG are also here, so we have a long-time cooperation with EVG, and we use a EVG 770 wafer stepper, which we have modified. Instead of 8-inch wafers, we are going to use 700 millimeters times 380 millimeters for this step and repeat process, where we start with a master, and with the wafer stepping process, we can use this stage here to achieve a stage positioning accuracy of 3 micrometers and an overall overlay alignment accuracy smaller than 1 micrometer. This is one of the unique selling propositions that we have at the moment and offer at the moment. So because when you start, usually with your application of a small master, then you have always a certain distance between those different imprints. And what we have worked on and can provide is that we get a almost seamless stitching of these masters by certain technologies that we have developed over the last years. Here's an example that we also show in our booth. So we started for an application in lighting, where we started with a hexagonal master, which was kindly provided by Power Photonics. And after certain experiments, we were able to produce structures like that, where you virtually cannot see any stitches here anymore in the, at the end in practical application. Here you see the roll-to-roll results. So first, the polymachine was galvanized by our partner CSEM, and we took that on the roll, and then you can see here at maybe 1 meter per second or half a meter per second in this case, you can have this imprinting on a roll-to-roll basis continuously. If it's a nickel shim, it's lasting very long, and you don't have to replace that so frequently. Okay, another very nice example that we did in this fabulous project was together with Austrian company Swarovski, which is maybe well known to you, and they wanted to have freeform microfacets, UCD facets, to realize the sparkling effect of luxury goods. And we had the task to do the seamless step and repeat upscaling for roll-to-roll production. The master was in this case provided by Swarovski, and we realized the step and repeat upscaling on a specific material with a low AB number, which does mean that it has a very high dispersion. And we succeeded quite well. What I can show you here. See very nice effects of this sparkling nature. Things like that are fancy, of course, and the problem here was that we really had to manage that these facets have been very, very accurate, very flat, and very exact, even after shrinking of the polymers. You see the roll-to-roll manufacturing, we can do that on both sides. So in the first cycle, the first side is coated, and in the second cycle, then we switch to the other side, and we can do here both side imprinting of these structures in a continuous way. Right, here you see the effects, and you can also see that outside. Our partner Fraunhofer FAB was also doing a metallization, so you can also do then a reflective effect, but also in transmission. This gives a very good and very nice effect. You see also the different colors of the LED, which is intended here. Okay, another use case example was interior lighting for trains with Austrian company Eisenbacher, and here the freeform microlenses were designed to achieve homogeneous, large area, direct lighting, direct lit luminaire, is it called, with some linear lens arrays, and these have been specific freeform optic lenses. Here you see it a little bit better, I think. So it was a lens which was divided into, I think, many dozens of segments, and every segment has its own freeform scape, freeform surface. So, and this one is producing a rectangular distribution of light out of a circular LED. Also in the polymer shim with step and repeat process, and at the end Morphotonics was doing also here the roll-to-plate lens arrays. Also for Morphotonics is here today with us. Right, still here we did the same thing on roll-to-roll. So you either roll-to-plate or roll-to-roll is possible with the same structures, and you can see here the production of a lot of different beautiful lenses, all of the same quality. Thank you for your attention. I'd like to thank all my co-workers which have been contributing to that. In the team, Ursula Walfinger, Roman Hartmann, very active and fabulous. I'd like also on this stage to say thank you to all the fabulous partners that have worked with us over the last years. It was really big fun, and we have learned a lot all together, and hope to bring the story a little bit further on with the fabulous one-stop shop association. And Piotr will be one of the central parts of that. Thank you very much.